Hi, I'm Hamel, and I'm here to talk about how you can create magical data products using sequence-to-sequence models. But first, I want to introduce myself. Currently do ML research at Github. You heard from Claire yesterday. She also does ML research at Github. Specifically, I do machine learning on code and NLP. You'll see what that means later on. Before GitHub, I worked at Airbnb and also at Data Robot, and then before that, I worked in consulting for a really long time. Okay, so why am I giving this talk? So first of all, I live in San Francisco right now. I'm actually moving to Portland in a couple of weeks, so I just wanted to, yeah, thanks, yeah. Yeah, and I wanted to meet the machine learning community, and so I thought this conference might be a good way to do that. And then secondly, I think sequence models are really cool, and a lot of people may not know about that. That word might sound scary, and it doesn't have to be scary, and I think they're actually very useful. And I'm going to show you how. But the goals, I have two goals for this talk. One is to reduce fear of kind of deep learning and this technique in general. And then also to motivate you to go learn more about it. But I don't expect to actually teach you all the nitty-gritty details of sequence models, because that would be too much for a talk. And that's not the way I learn. Watching people give a talk, I have to do it myself. So I'm just going to kind of set y'all up to learn more about it. Okay, so what are the prerequisites for this thing I'm going to talk about, sequence-to-sequence models? So a lot of people come ask me, okay, how do you, in deep learning, do you need a PhD? And the answer is no. In fact, a lot of data scientists at GitHub, where I work, have PhDs, but some of the most heaviest users of deep learning don't have a PhD. So you don't really need to have a PhD necessarily to do deep learning. There's nothing, there's not really that barrier. And then also there's a misconception that maybe you have to be really good at math, you have to love math, you have to understand all these equations, but really you can get really far with high school level math in these things, and I'll kind of talk about that more. But something that is a prerequisite is you have to be pretty comfortable writing code, and also some prior experience with deep learning and specifically RNNs for this technique. That's really useful. And then, okay, so sequence models, so I think some people may not know about that because in a lot of deep learning courses, they're kind of at the very end, or the very tail end, and sort of reserved for, let's say, like some very advanced topic. So on the left-hand side, that's kind of the core syllabus of Andrew Ng's deep learning class, the new one. So course one is neural networks, like basics, and it keeps going. The last thing is sequence models, which includes sequence models. And then similarly, another MOOC that I really recommend, Jeremy Howard's Fast AI. If you haven't taken that, it's an amazing MOOC. Only until the second part, you might learn about sequence models, and then also not until lesson 11. And so a lot of people give up by that point, and they don't get to it. And I think sequence models is a really good workhorse for when you have text data. It's not only for text, but it's really good when you have text and can apply to a lot of people's use cases. So I think it's something that maybe a lot of people may not get to when trying to learn about deep learning. Okay, so I made this statement that you can get by with without knowing, with just high school level math. So like how do you do that? And so I just want to share kind of how I go about learning deep learning or learning new architectures of deep learning, or how you can get unstuck if you are trying to learn something, including this talk. And I'll talk about this more, but what I do is I think of these different layers as APIs. So in RNN, I think of it as an API. I try to think about what is the input this layer expects, and what is the output that comes out of this layer, and what does that represent? And by thinking about it that way, at that level of abstraction mentally, I free myself up to kind of get unstuck and move forward. And then going back into the math is helpful later on, but this is a good way to reduce fear if you're going through this. And I'll show you a concrete example of what that means. So, okay, so for example, RNNs. This is a very oversimplified, actually I'm skipping a step, but on text, this is what I mean. You start with some text. Okay, this is a sequence, and then you might transform that text to integers, to be represented as integers, and then you feed that into an RNN, and then you get some output out. So this is an example of what I mean by thinking about layers as APIs. You understand that, okay, an RNN is something where you give it a sequence, and it extracts some features from that sequence. So in goes your data that's some kind of sequence. It can be a time series, it can be text, whatever it may be, and then the output of the RNN is just some latent features about that sequence. And that really helps if you think about it that way, because that really helps as you stack these layers and think about what's going on. And this is a picture of Keras documentation. It's actually a good library if you're going to think about deep learning in this API sense. And it's really important to know the input shape of what these layers expect, and then the output shape of what's going to come out. And really understanding that is key. I hope that kind of explains a little bit more. Similarly, with convolutional neural networks, which you might be more familiar with, essentially, you can think of it the same way. You have a picture. You want to represent that picture in some numerical form, which I'm not going to talk about because I don't want this talk is not about teaching RNNs or CNNs. This part is just about reducing fear. And so we stick this representation of this picture through a CNN, and what comes out of the CNN is also extracts features from the image. So similarly, like as an RNN, it extracts features from sequences. CNN will, or a convolutional layer, I shouldn't say CNN, will extract latent features out of an image. And if you think about it that way, that can help you get unstuck when going through these examples that I'm going to show you. And this is the same thing here, Keras documentation. Again, if you think about an API, it expects a certain input and a certain output. And the key is to understand what is exactly this input. And for example, it's pretty small, you can't read this, but it's expecting a matrix of a certain dimension. And then output is similarly another matrix of some dimensions. And the key is, what do those mean? What do the outputs mean? And what do the inputs mean? And really understanding that. And that's a way, again, to get unstuck and not get too bogged down in a lot of math and kind of stick to intuition. Okay, so like I said, the point of the last two slides, I'm not trying to teach RNNs and CNNs. I'm just trying to give you a way of thinking as you approach this subject so you can reduce fear, because that's one of my goals, is to reduce fear of deep learning. And just keep moving if you get unstuck. It's kind of share something that I do mentally with you, as we go through this. Okay, so sequence-to-sequence models. That's what this talk is about. And so I want to show you. So essentially, sequence-to-sequence models can be used for a lot of things. Some really popular use cases is like a translation, machine translation, or text summarization. And so, for example, this is going from English to French. So we have a sequence-to-sequence model, and its very simplest forms is 2 RNNs. This left-hand side is an encoder. That takes the sequence, the weather is nice, the English phrase, and it extracts features from that phrase. And it sends those features to the decoder, and the decoder then figures out how to take the semantic meaning of the weather is nice and translate it to French. And the part where I talked about API and understanding what is coming out of these layers is really important, becomes key. So the part where the LST, this encoder, extracts semantic meaning from the weather is nice, and since it's the decoder, that's really interesting because you can take this internal state of the encoder and you can reuse that for all kinds of other stuff. And I'll show you an example. And actually, this is okay. So you don't have to read this. Don't try to read this. You're gonna hurt yourself. It's not meant to be read. What I'm just trying to show you is this is real. This idea that I think of layers as APIs, and I draw them out, and I understand what's going in and what's coming out mentally. And so a lot of people think that deep learning involves like some blackboard, a bunch of equations everywhere, and I have like sitting in my room, and that's not what it looks like. I just think about it conceptually with layers, what's going in, what's coming out. I just want to reinforce that. So don't worry about reading this. Exactly. Okay, so this task of, I want to kind of give you some, so hopefully I reduce some fear. The next thing I want to do is get you excited about what sequence models could do. And then lastly, I'll give you some concrete resources that I think are very approachable. So this is one problem I've worked on. It's taking GitHub issue bodies and then trying to construct what the issue title would be, or summarizing the GitHub issues. Now that might not seem like that useful of a use case, but remember the sequence model takes the input and it passes this hidden state to the decoder. So actually, this hidden state is actually really useful as well. And so I know this is really small. I have a zoomed in version. Let me see. Maybe that one's better. It's still kind of small. But essentially, this is an example where we have an issue body. Right now, okay, so the issue body says, right now your profile link is something. This is fine, but it would be really cool if there was a way to share your profile with other people. Basically, someone's asking for like some feature request. And the sequence model summarizes that and wants to summarize that whole thing into add a link to your profile, that's what the person in the issue is asking for. And that's pretty magical that machine learning can do that. That's really interesting. But what's more interesting is you can take that hidden state from the sequence model, the thing that's getting passed in between the encoder and decoder, and you can use those as features for all kinds of other tasks. So now I can build a recommendation system to see what issues are similar to this issue, because I have those latent features that I extracted. And so these are some similar issues. They're also asking for feature requests. And you probably can't see them from the back, but that's okay. I'm going to share these slides and more detailed examples in the end, so don't worry. Okay, let me go back to the slides. Present. Okay. Oh yeah, and by the way, so everything I'm going to show today is completely open sourced, and there's end-to-end example of how you can reproduce the exact same thing you see today with code and data yourself. And there's no equations or crazy stuff. You can do it, a very step-by-step example, but I'll get to that in a little bit. There's this live demo as well of summarizing GitHub issues. Actually, I won't do that right now. We'll just keep going. So more magical stuff. Okay, so summarizing GitHub issues. Okay, that's great. This kind of sounds cool, recommendation of issues. Maybe you're not that excited about this yet. You're like, yeah, I don't know. Okay, summarization of code. Let's see if we can get people excited about that. So here's a function. It's a Python function. It's doing something by removing a virtual environment. And the model summarizes that function and says that, okay, it's, well, this GIF is moving too fast. We'll come back to it. This one, let's just wait till it cycles, because timing is. Okay, so here we go again. So yeah, removing this virtual env, that's what this code is doing. And so the idea is, can we can we summarize what the code is doing? And the prediction is, yeah, it's removing the virtual F from the directory. So that's a little bit more magical. Like, that's amazing. You can go from code to this. And same thing, we have something about mean squared error, regression loss. That function was calculating that. So sequence model can be used to do this. I also provide this. This is open source. And I'll show you how to read this in detail. I know this is like kind of hard to digest when I'm just showing you. But maybe you're not that excited about that. Maybe that is not that exciting. Which, okay, I can show you one more thing. So semantic search of code. Okay, so this is the kind of last thing I want to show you to get you excited about sequence models. And before I show you this, I just want to explain what it is. So today when you're searching for code, it's keyword search. So you have to know the syntax you're looking for. You have to know, or you have to be able to anticipate what the comments in the code might be. But wouldn't it be great if you could search the code for the meaning of what the code does? That would be really interesting. That sounds like science fiction, right? I know, but let me show you something. Let me show you this. Okay, so this is something which you will be able to do, because it opens like an end-to-end tutorial on this. But this is concatenate files together, and then we find code that does that. So this is some code that merges files, a search that concatenate files together. Scrape data from a website. That's code that does that. And this is searching the semantic meaning of code. And sequence model is a part of this. It's not driving the entire thing, but is a key element of this. And then execute SQL query and return results. Again, find the function that does that. And it's searching the meaning of what the code does. So it's really magical. Another one, build convolutional neural net. Search for that. And then you can see they're finding a function that helps build a convolutional neural net, a VGG19, which is a popular architecture, and this is VGG16 right here. So it keeps going on and on. You can keep searching, and actually it's pretty interesting. Check if process is still alive. Okay, that's another one. So this checks if process is still alive. So that's extremely magical. That's not something that when I first got into machine learning, like, I would think this is science fiction. Like, again, start a Flask app. This is starting a Flask app. So this is all Python. This thing is prototyped to search Python code. And it goes on and on. So hopefully by this point, you're really intrigued by sequence-to-sequence models. That's the point of this presentation. So the next thing I want to do is let's see. So yeah. So everything I've shown today, I have a very detailed blog. The data is open and the code is open. A step-by-step tutorial on how to do this yourself. And you can reproduce all the examples that I've shown today. Again, all the way from beginning to end, yourself with a very detailed explanation. You can go here and you can find that. And so the function summarizer, the issue summarizer, and also how to the search thing. And the thing that I think is most useful is you can generalize this to your stuff. So it's not about code, really. I'm just using this as an example for you, but I think you can learn from this is the point. So I hope you enjoy this talk. That's all that I have. Yeah.